So, welcome to the lecture series on mathematical methods and applications. So, in the last lecture we have seen that what Fourier series are and how we can expand a function f(x) in the form of cos and sine terms. Okay. So, now we will see that when the Fourier series is convergent. So, let us see first convergence of Fourier series for continuous functions. If a periodic function f(x) with period 2l is continuous in interval minus L to plus L and has continuous first and second derivatives at each point in that interval, then the Fourier series which we have already discussed a0 by 2 plus summation a n cos n pi x by L plus summation b n sin n pi x by L of f(x) is convergent. Okay. So, what is the proof? So, proof we can see. Now, in this series a0 by 2 plus summation n from 1 to infinity a n cos n pi x by L plus summation n from 1 to infinity b n sin n pi x by L. In this series a0 we already know is given by 1 upon L minus 1 by minus L to L integral minus L to L f(x) dx. A n is given by 1 by L integral minus L to plus L f(x) cos n pi x by L into dx, and b n is given by 1 by L integral minus L to plus L f(x) sin n pi x by L into dx. So, this we already studied in the last lecture that these are this is given by Euler's formula a0, a n and b n. Now, if we see a n, okay, a n is nothing but what? A n is given by 1 by L minus integral minus L to plus L f(x) cos n pi x by L into dx. Now, you integrate it by parts. Okay. You take it first function this, second function this, integrate by parts. So, it is nothing but is equals to 1 by L. Now, first as it is integration of second, it is nothing but sin n pi x by L upon n pi by L from minus L to plus L minus integral derivative of first and integral of second. Now, when x is L, so it is sin n pi which is 0, and when x is minus L, so it is again sin minus n pi which is again 0. This first term is 0, so it is nothing but minus, it is L cancels out, it is minus 1 upon n pi, and it is integral minus L to plus L f dash sin n pi x by L into dx. So, this we obtain. Now, again you apply by parts. So, it is first and second. So, it is minus 1 by n pi. Now, first as it is integration of second is nothing but minus of cos n pi x upon L divided by n pi by L, and it is from minus L to plus L minus integration derivative of first integration of second, that is plus cos n pi x by L upon n pi by L into dx. Now, it is minus 1 upon n pi. Okay. Now, since f dash s is continuous and f is periodic, so f dash L is same as f dash minus L. Okay. Since f(x) is continuous and it is periodic, so f dash L will be same as f dash minus L, and at x equal to L and x equal to minus L, this value is same, which is minus 1 ki power n. So, the first term will be 0. Okay. The plus, it is L upon n pi integral minus L to plus L f double dash x into cos n pi x by L into dx. Okay. This is 0 because function is periodic, that is f of x plus 2l is same as f of x, and derivative is continuous. So, f dash of x plus 2l is also equal to f dash x for all x, and when you substitute x as minus l, so f dash l will be same as f dash minus l. Okay. So, these two terms are same, f dash l is same as f dash l minus l, and at upper and lower limit the value of this is same, this term is 0, and we left with this expression. Now, we have to show that anyhow that this is convergent. So, to show that this is convergent, again since f double dash x is continuous and in the interval minus l to l, so we can say that mod of f double dash x will be less than m for some m, because it is continuous. F double dash is continuous in the statement as given in the statement itself, that f double dash is continuous. So, f double, there will exist some m such that f double dash will be less than capital M. So, if we apply this over here, so mod of a n, and mod of cos of n is always less than equal to 1, mod of cos of nx upon L is always less than equals to 1. So, mod of a n will be less than, strictly less than 1 upon n pi integral minus L to plus L. We can take mod inside, mod of f double dash x into cos n pi x by L into dx, which is equal to 1 upon n pi, it is less than or okay, it is less than mod of this, it is less than mod of this, mod the entire expression. Now, when you take this expression inside, when you take this inside and applying these inequalities, so this is nothing but less than minus L to plus L m into 1 dx, which is nothing but, okay. Now, this into this is also there. So, it is L upon, sorry, it is L upon n square pi square, L upon n square pi square. So, it is nothing but 2 m L upon n square pi square. Okay. So, a n will be less than this. Now, similarly, we can obtain that mod of b n will be less than 2, similarly it will be less than this we can similarly obtain. So, so what about this series? So, what about this series? A naught by 2 plus summation n from 1 to infinity a n cos n pi x by L plus summation n from 1 to infinity b n sin n pi x by L. This mod will be less than mod a naught upon 2 plus. Now, this mod of a n in each, for each n, mod of cos n x is less than equal to 1, mod of b n which is less than this, and mod of sin n x by L which is less than equal to 1. So, what we will obtain finally, this is 4 m by L upon pi square will come outside, 2 from here, 2 from here, it is 4 m L upon pi square, and it is summation 1 by n square, that is 1 by 1 square plus 1 by 2 square plus 1 by 3 square and so on. Okay. Because when you take the mod and when mod come inside in each term, then using these inequalities we will obtain this expression, because it is mod of a n a naught by 2 plus mod of a n is less than 2 m L by n square pi square, and mod of this is less than equal to 1. Again this is less than equal to 1. We know that summation 1 by n power p is convergent when p is greater than 1. So, here p is 2, so it is convergent, as this series is convergent, and this series is convergent means inside the series is also convergent. Okay. This series is convergent means because f x is always less than equals to mod of f x. Okay. and if fx is convergent, then this fx is also convergent. Okay. So, this series will be convergent. So, hence we can say that if a function is a periodic and first and second order derivatives are continuous, then this series is convergent, this series of fx is convergent. So, here is this is the same proof which I have discussed here. Okay. Now, piecewise continuous function, we have already discussed this thing in Laplace transforms also, that piecewise continuous means that you divide interval a comma b into finite number of sub intervals, and if in each sub interval function is continuous, we say that the function is piecewise continuous. Okay, the same thing we will define here. Suppose a function is said to be piecewise continuous in minus L2 plus L if function is defined and continuous for all L except at finite number of points. Okay. If a function at a point say x naught is not continuous, then left hand limit and right hand limit at that point exist and finite. Okay. That means discontinuity are of jump type. Okay. Now, at an end point of interval, that is at minus L and plus L, if it is minus L, the right hand limit, if it is plus L, then the left hand limit exist and are finite. So, then we say that the function is, if these three properties hold, then we say that the function is piecewise continuous in minus L2 plus L, or in other words we can define the same definition, that to divide interval into finite number of sub intervals and each sub interval function is continuous, and if there is a discontinuity, that must be of jump type. Okay. Now, if a function is piecewise continuous, what is the convergence of condition for Fourier series? A function fs can be expressed as a Fourier series this in the interval minus L to plus L, where a naught, a n, b n are constants provided function is periodic with period 2L, single valued and finite. Function is piecewise continuous in minus L to plus L, piecewise continuous we already discussed what it is, and fx has left hand derivative and right hand derivative at each point in that interval. So, this is if function is piecewise continuous. If these properties holds, then it is converges to this expression, then function fx will converge to this expression. Okay, can be expressed in this way. Okay. Now, we have a theorem that if fx and f dash x, that is the first derivative, be piecewise continuous function on the interval minus L to plus L, then the Fourier series of fx converges to the fx at the point of continuity. If there is a continuous point, then fx will converge to, suppose x naught is a point of x naught is a point in minus L to plus L where it is continuous, then fx will converge to fx naught. Okay. But if it is a point of discontinuity, say x naught belongs to minus L to plus L, then Fourier series will converge to the average of left hand limit and right hand limit at that point, will converge to the half of fx naught plus fx naught minus. Now, at both the end points of the interval minus L to plus L, if you take minus, what is the value of function at minus L, what is the value of function at L, then the Fourier series will converge to half of f of minus L plus, that is the right hand limit at x equal to minus L, and fl minus, that is the left hand limit at x equal to L. The average of these two will be the value of the function at the end points of the interval minus L to plus L. Okay. I am not discussing the proofs here, okay, proof of this theorem. So, the proof can be obtained. So, this results we will use while solving some problems. Now, let us try this problem. Find the Fourier series expansion of the function this and deduce this expression. Okay. So, we will solve the problem in the usual way as we did in earlier to find out the Fourier series expansion of this function. So, function is periodic. Okay, we assume here function is periodic of period 2 pi. Function is defined from minus pi to plus pi, but function is periodic, that is period is 2 pi. Okay. So, let us find a naught first. So, what will be a naught? A naught will be 1 by pi minus L to minus pi to plus pi fx dx by the definition. So, it is 1 by pi. Now, from minus pi to 0, it is nothing but minus pi and from 0 to pi it is nothing but x. So, using this it is nothing but 1 by pi, and it is minus pi 0 minus minus plus pi, and it is plus pi square by 2. So, that will be nothing but minus pi by 2. So, that is A naught. Now, if you find an is nothing but 1 by pi integral minus pi to plus pi fx cos nx dx, because here L is pi, here L is pi. So, instead of cos n pi x by L, if you take L equal to pi, so it will be nothing but cos nx dx. Okay. Now, it can be expressed as written as 1 upon pi integral minus pi to pi, it is minus pi to 0, it is nothing but minus pi, it is nothing but minus pi cos nx dx plus 0 to pi, it is nothing but x cos nx dx. Now, it is 1 by pi, minus pi will come out, it is sin nx upon n from minus pi to 0 plus it is x sin nx upon n minus 1 into integral of this, that is minus minus plus cos nx upon n square from 0 to pi. So, it is nothing but 1 by pi, it is minus pi. Now, it is 0 when x is 0, it is pi, it is 0 again when x is minus pi. So, this term is 0 plus again this term when x is pi and 0, it is 0. So, it is 0. Now, here it is 1 by n square times, it is minus 1 ki power n minus 1. This is nothing but 1 upon pi square n minus 1 ki power n minus 1. So, this is this will be a n. Okay. Now, what is b n? b n will be nothing but again 1 by pi, I break it here, minus pi to 0, it is minus pi sin nx dx plus 0 to pi, it is nothing but x sin nx dx. Now, when we take it, it is 1 by pi, it is minus pi, it is minus cos nx upon n, you integrate it, okay, from minus pi to 0 plus you apply by parts here. So, we will obtain it is x minus cos nx upon n minus 1 into minus sin nx upon n square. So, it is 0 to pi. So, when you simplify this, it is 1 by pi minus minus plus cos 0 is 1 minus, it is minus 1 ki power n, 1 by n will come out. Okay. Now, here plus this term is 0 when x is pi and 0 because of sin nx, and this term is 0 when x is 0, only one term remaining, that is minus of pi in by n into minus 1 ki power n. Okay. Now, this is minus and now what we will obtain from here? It is nothing but it is minus, and here it is also minus, it is nothing but it is okay. Let us see it once again, it is minus pi, it is minus cos nx upon n minus pi to 0. So, when 0 it is 1, when minus pi it is minus 1 ki power n, so it is plus. Okay. Now, x, the integration of this is minus cos nx upon n, okay, minus derivative of this and integral of this. So, that is minus sin nx upon n square from 0 to pi. Now, when it is 0, so it is 1, it is this, and when it is pi, it is minus pi upon n minus 1 ki power n. Okay. So, it is nothing but something like 1 upon n will come out, pi will cancel, and it is 1 minus, it is 1, it is minus of this and minus of this will add up. So, it is 2 times, so it will be minus 2 times minus 1 ki power n. Okay. So, this will come here. So, now we have a naught, a n and b n in our hand. So, what will be the Fourier series now? A naught is minus pi by 2. So, Fourier series of f x will be nothing but a naught is minus pi by 2. So, a naught by 2 plus summation n from 1 to infinity. It is 1 upon n square pi minus 1 ki power n minus 1 plus into cos n x plus summation n from 1 to infinity 1 upon n into 1 minus 2 into minus 1 ki power n into sin n x. So, this is the Fourier series of f x which we will obtain from here after simplifying. Now, so this will converge to this, okay, because function is, we have seen that the conditions of convergence of Fourier series of piecewise continuous holds here, okay. Now, we want to deduce this expression. So, it is 1 by 1 square. Now, n square is only here. So, that means this term is there, but we do not want this term. So, we can put x equal to 0, okay. We put x equal to 0. So, it is nothing but f 0 is equals to minus pi by 4 plus summation n from 1 to infinity 1 upon n square pi and minus 1 power n minus 1 and cos 0 is 1, okay. Now, what will be f 0? Because it is not continuous at at x equal to 0, left hand limit is minus pi and right hand limit is 0, okay, because what is f 0 minus? F 0 minus is nothing but minus pi and f 0 plus is nothing but 0 by the definition of the function. So, what will be f 0? Is the average of 2, 1 by 2 minus pi plus 0, which is nothing but minus pi by 2. So, this is minus pi by 2 is equals to minus pi by 4 plus 1 upon pi, come outside. When n is 1, so it is minus 1 minus 2, minus 2 upon 1 square. Now, when n is 2, it is 0. When n is 3, it is again minus 2 upon 3 square, minus 2 upon 5 square and so on. So, when you simplify this, it is minus pi by 2 plus pi by 4 is equals to minus 2 upon pi, 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square and so on. So, it is minus pi by 2 minus pi by 4, which is minus 2 by pi into this expression. So, hence the value of this expression is nothing but pi square by 8, pi square by 8. So, hence we obtain the required result. So, in this way, if a function is discontinuous at a point, what I want to illustrate in this example, I want to illustrate that if you want to find out the value of the function at a point where it is discontinuous, then to find out the value of that point is nothing but the average of the left hand limit at that point and right hand limit at that point, okay. You find out left hand limit and right hand limit and the average of these two will be the value of function at that point. So, all other things are as usual we did earlier, but the important point to note here is how can we find the value of function at a point of discontinuity, okay, if function is discontinuous. Now, it is the same type of example. So, we can easily solve this example also. Again, suppose you want to find out a naught. So, a naught is nothing but now it is from minus pi to plus pi, it is 1 by pi integral minus pi to plus pi f x dx. So, it is 1 by pi. Now, you can break it from minus pi to minus pi by 2, it is minus 1. From minus pi by 2 pi by 2, it is 0, and from pi by 2 to pi, it is 1. So, you can simplify this, it is a very simple thing, you can easily simplify, it is minus pi by 2 minus plus, okay. Negative will come outside actually, negative of minus pi by 2 minus plus pi, and it is 0, it is pi minus pi by 2, and which is nothing but, when you simplify it, so it is 0. Okay. Now, what will be a n? Again a n you can compute, a n will be 1 upon pi, again you will break the interval into 3, okay. From minus pi to minus pi by 2 it is minus 1 into cos nx, from minus pi by 2 to pi by 2 it is 0, no need to calculate that, it is 0, plus integral pi by 2 to pi it is 1 into cos nx dx. Now, it is nothing but 1 upon pi negative of sin nx upon n from minus pi to minus pi by 2 and plus sin nx upon n again from pi by 2 to pi. So, it is nothing but 1 upon pi minus of sin, minus 1 by n comes out, and it is sin okay, it is negative of sin n pi by 2, and sin pi is 0. Again here sin pi n pi is 0, and it is nothing but minus of 1 by n sin n pi by 2, which is nothing but again it is 0. So, it is 0, okay, that you can easily simplify. Similarly, when you find bn, so what will be bn? It is 1 upon pi, again minus pi to plus pi minus pi by 2, it is minus of sin nx dx, and plus pi by 2 to pi it is sin nx dx. So, when you simplify it is 1 upon pi, it is minus plus cos nx upon n from minus pi to minus pi by 2, and it is minus of cos nx upon n from pi by 2 to pi. So, this value is nothing but 1 upon pi, it is cos n pi by 2 upon n, 1 by n is comes out, and minus 1 ki power n minus again minus 1 ki power n and minus cos n pi by 2. Is it okay? 1 upon n pi will come out, and it is sin cos n pi by 2 minus of cos n pi minus 1 ki power n, negative is here. So, it is nothing but minus 1 ki power minus 1 ki power n, and it is minus of cos n pi by 2. Okay. So, it is okay, minus is outside. So, minus is outside, so minus will be here, something like this. Okay. Minus is outside. So, it is nothing but 1 upon n pi. So, it is 2 times, 2 will come outside, 2 times cos n pi by 2 minus 1 ki power n. Okay. So, only we have in this expression a naught a n are 0. So, for this function f x we have only the sign terms on the right hand side, because a naught and a n are 0. Okay. So, we have on the right hand side only sign terms. So, what will be f x? F x will be nothing but summation n from 1 to infinity, 2 upon pi can come outside, it is 1 upon n, and it is cos n pi by 2 minus 1 ki power n into sin nx. So, this will be the expression of this function. So, f at pi by 2 will be nothing but 1 by 2 f of pi by 2 minus plus f of pi by 2 plus. So, it is nothing but 1 by 2, f of pi by 2 minus is 0 and f of pi by 2 plus is 1. So, it is nothing but 1 by 2. So, you substitute x equal to pi by 2 both the sides. On the left hand side we have 1 by 2, and on the right hand side we have 2 upon pi, 1 minus 1 by 3 plus 1 by 5 and so on. So, value of this is nothing but 1 by 2. Okay. So, in this way if you want to find out Fourier series, we first have to find out a naught, a n and b n, and if we want a series expression, value of the series expression, and we have to substitute x as a point where function is discontinuous, then you first find f x naught minus, f x naught plus, and the average of these two will give the value of the function at that point. So, thank you very much for this lecture.